In this last example 5, we have a graph, and the graph represents the number of balls thrown over time. So we've got minutes and number of balls thrown. This could be at practice or something like that. And so it says, it first asks us to name the plots pointed on the graph using their ordered pairs. So the first point that I see on that graph is at 0, 0. That's right here at the origin. The next one I see is 1, 5. 2, 10, 3, 15, 4, 20, and 5, 25. In this situation, we know we have a constant of proportionality, or we have a proportional relationship because this is a straight line that goes through the origin. Notice that when I wrote my ordered pairs, I wrote them inside parentheses with a comma. And then down here, find the constant of proportionality. Hint, set up the ratios, then divide y over x. So I can do 5 over 1, 10 over 2, 15 over 3, 20 over 4, or 25 over 5. Don't use 0, 0 because that just shows that we started at 0 minutes with 0 balls thrown. It is a requirement that it goes through the origin to be proportional, but we don't want to use 0 divided by 0 for our constant of proportionality. We want to use one of our points once we get past the origin. So in this case, I'm going to set up a couple just to show you. 5 over 1 is 5. 10 over 2 is 5. 15 over 3 is 5. 20 over 4 is equal to 5. And 25 over 5 is equal to 5. So our k value, our constant of proportionality, is equal to 5. So predict how many balls would be thrown in 6 minutes. Hint, write an equation first, y equals kx. So in this case, we've got y equals 5x because 5 is my k value. I plug that in here. Y equals kx. And so then y equals 5 times 6. We're throwing 5 balls a minute times 6 minutes. And that should give us, 5 times 6 is 30 balls. What does the 0.15 on this graph represent? Well, for every 1 minute, we've thrown 5 balls, or for every 5, we throw 5 balls per minute. This point at 1.5 represents our unit rate. It's telling us that in 1 minute, we've thrown 5 balls. And so our unit rate here is 5 balls thrown per minute. So we're going to be continuing these examples and going through this stuff in class, but today I just want to do a quick review with you. We defined what proportional relationships are. We looked at them on graphs and said they had to go through 0, 0 and be a straight line. And then we looked at some more proportional relationships. We looked at a proportional relationship with a table. We looked at a proportional relationship with words. And then we looked at another graph and used our knowledge to come up and answer some questions about the constant of proportionality and predicting some things using our constant of proportionality, using our proportional equation that we wrote given the graph, given the table, or given the words. And so that is where we're going to end today for proportionality and proportional equations.